one of these shapes yet. So this is page 5 of the review. This is question number, surface area of right pyramids and cones, number 1C. Okay, so we're gonna do that one, Alex, for you. 1C, trying to find the surface area of the, what are we dealing with here? A right prism, I guess we are. You'll notice on the formula sheet, it just says sum of all the areas of the sides. So what we need to do, we need to figure out what that's gonna look like. So we need to figure out what all these sides are that we're dealing with. I'm gonna try to cruise through this one maybe a bit faster because it doesn't look very good. All right, answer in millimeters, and you'll notice that they're trying to trick me, but I'm smarter than that now. That's 8 millimeters just divided by, or multiplied by 10 to get millimeters. And what sides am I dealing with here? So I have the bottom, which is a rectangle. I have this front face, which is a rectangle. I have this back face, which is a rectangle. And then I have the triangle on the front and back. So I'm thinking the picture I've drawn there doesn't look terrible, and hopefully you can kind of understand what I'm talking about. And I'm gonna draw a really goofy looking formula for this. I'm gonna take surface area, maybe I'll do this in black. Surface area is going to equal the area of the green rectangle. I'll just say a green rectangle. I'm going to add to that the area of the blue rectangle. And then I'm going to add to that the area of the black rectangle. And then I'm going to add to that my triangle. So I have a triangle on the front. Maybe I'll just outline it in red so I won't wreck everything. And then I have the same triangle on the back. So I'm going to have 2 times the area of a triangle. So that kind of hopefully makes sense a little bit. Hopefully. I'm just going to go do this in one go. The green triangle on the back, the length is 8 millimeters, and then the width is going to be 16. Now, if you're not doing these in the same order as me, again, it doesn't really matter. The blue one on the front, I don't know this length yet, so I'm going to have to calculate that using my Pythagorean theorem. Can't get away from it. So we're going to need this for our triangle. Or no, we won't. We don't need this for the triangle. But if you can think about the triangle, I know this is 12. I know this is 16, but I don't know what this is. And I need to know that to find it here in the question. So I'm going to use the Pythagorean theorem. I'm going to go 16 squared plus 12 squared is, well, let's just go question mark squared. Why not? 16 squared plus 12 squared is 400. Square root of 400 should be 20. And it is. So 20 is equal to the question mark. That means this side is 20. And that means I'm going 8 millimeters times 20. The black is the bottom, so I'm going to go 8 millimeters times 12. Then my triangle is going to be, of course, base times height divided by 2. And in this case, my base is 12, my height is 16, and I'm going to divide that all by 2. Abby, I'm just reading your question, and I will get to that momentarily. So 8 times 16 is going to give me 128. And I'm going to add to that 8 times 20, which should be 160. And it indeed is. 8 times 12, you know your 12 times tables. And 12 times 16 divided by 2 is 96 as well. So 128 plus 160 plus 96 plus 96 gives me 480 millimeters squared. Oh, and I forgot the 2 times this. I didn't carry my 2 down from above here. So scratch that. Forgot my 2 times my 96, and this is all times 2. So 128 plus 160 plus 96, and 96 times 2 is 192. 576 millimeters squared. So the reason I had the 2 in there and I forgot to carry it down is I have 2 of the triangles. I have the triangle on the front and the triangle on the back. So I had 3 rectangles essentially and 2 triangles. If I find the area of each of those, I should be on the right track. So hopefully that helped you out a little bit, Alex. Again, those types of questions don't have the formula kind of associated with them like the spheres and everything else did. So just a matter of figuring out what shapes there are. You have 3 rectangles, 2 triangles, find the shapes and add them together. Abby, it'll just take me a second to look at it because it's right here. Side is 750, it's 6 meters by 6. So I think it's just a unit thing, 6 by 6, and then 750 is 7.5. You'll notice a lot of times, and it'll even say in the questions that these pictures aren't drawn to scale, and they aren't. We just get like a picture of a rectangular prism and then we just throw whatever numbers we want at it. Sometimes, especially for the measurement stuff at the beginning, you'll notice on your formula sheet, my bright lighting, you won't be able to pick it up very well, but there's a ruler right on your formula sheet. And sometimes at the very beginning of your provincial exam, it'll say, these images are drawn to scale. And they will ask you to physically measure them using the funky little ruler that you get on your formula sheet. So if you have a paper exam or digital, I'm not sure what we're going to have yet. I'm hoping for digital. The paper exams are kind of nice though. So sometimes it'll say pictures are drawn to scale, but unless it physically says this picture is drawn to scale, just assume they aren't because it shouldn't make sense and it won't. All right, there's one more question. Where was that? Number 6, a cone-shaped pile of topsoil needs to be covered with plastic. The diameter of the base of the pile is 20 meters and the height is 14, allowing an extra 20% so the plastic can be secured down. What is the size in square meters of plastic that's required? Obviously a bit of a spelling grammatical thing there, but let's draw a picture first. So I have a cone, it's a pile of dirt, and it tells me that the diameter of the base, so from side to side, is 20, and the height, so from the apex here to the middle, the height of my soil is 14. Making sure I'm reading this correctly. I want to find the surface area, but this is where we get like a little tricky because if I look at the surface area of a cone formula, it says pi r squared plus pi r s, where s is the slant height, which I still need to calculate. Someone want to just remind me who asked this question so I know to ask at the end. If we think about it, this pi r squared is the area of a circle. And in this question, this is a pile of dirt. Thank you, Taylor. So we don't need the circle because the circle is the ground. So all we're really interested in here is this pi r s. Then once we've found that, we're going to multiply it by 0.2 to figure out 20% of it, and then we're going to add that value on. So let's just go through this real quick. I'm going to draw this picture again to figure out my slant height. So I know I have my height. The slant height is the s, which I'm trying to find, and then I have the base, which is going to be 10. The height should be 14. And I'm going to find this. So I'm going to go 14 squared plus 10 squared is s squared. Add those things together. 14 squared is 196. So I get 296 is s squared. Take the square root of both sides. Hopefully you guys see the trend that's happening here. You're going to get 17.2 is equal to the slant height. So again, the surface area is going to be pi times the radius, which is 10, not the 20, give us a diameter, and the slant height should be 17.2. So pi times 10 times 17.2. So I get 540.5. Meters squared. And we're thinking about it, does that make sense? Well, this is a pile 14 meters high. So if we just think about that in terms of maybe just feet, because we can kind of relate that. 14 times 3, it's like a, 42-foot building. It's a big pile of dirt. The question asks allowing an extra 20%. So if this is a surface area of just that lateral surface area, I need to give it an extra 20%. So I'm just going to do this right below here. So I'm going to take this 540.5 and I'm going to multiply it by 0.2 to give me 20%. So that's 108.1. So this is to find the 20% extra. So 108.1 is the extra 20%. If the original TARP was the 540, and I have to allow an extra 20%, I'm going to have to add these two things together. So I'm going to take the 540.5, and I'm going to add the 108.1. So I'm going to end up with the 648.6. And again, this is meters squared. So hopefully that makes a little bit of sense. There would be. All right, so Abby is asking a question about the review. Would you like me to include my corrections? If you've done corrections kind of as I've gone through it, and you want to include those in like a different color or something, that would be awesome. Then I can just see, hopefully that something got fixed along the way. Just helps me kind of see your kind of thought process. So obviously, I'm not there with you to hear it. Is there any questions that somebody asked above that I didn't get to? And Alex just put a number 7. I'm just checking the clock, and we have till 10:20 today, so we have about 7 minutes or so. Obviously not enough time to get through the first lesson of Unit 1. So I don't mind spending a little bit more time on this unit because it's a little bit more difficult. And then when we get to Unit 1, things get a little bit more straightforward, or the questions have sort of fewer steps. And once you figure out the process, it's a little bit easier. So I don't see anybody typing that I missed a question. Number 7 on page 10 of the learning guide. And then first page learning guide number 2. So number 7, page 10, page 9, 10. Is that the guy we're talking about there? Is it the inside radius of a plastic pipe and the outside's 44? 12-meter length of pipe. This question, I think we did in the practice. I'm pretty sure I did that exact question already, except maybe the pipe was longer. Does anybody remember what lesson the cylinders was? I want to say 5. Practice, farmer needs paint, golf balls. I think we did this. I just can't remember which. Maybe it was in lesson 5. I'm certain I did it. Maybe it was 4, practice 4. Trough. Yeah, there it is. The inside radius of a plastic pipe is 40, and it was 100 meters long instead of 12. So you can see kind of how these questions work in the test banks. They'll just change the numbers on you and ask you the same question. So that was practice 4. So Alex, if you want to go back to lesson number 4, or I would be the day after. So it would be the beginning of lesson 5. The video's there. And that question is done. I explained it all. I can just leave that up. Maybe Mr. Ross can just zoom in on it for a second. And then we'll know, kind of have a bit of an idea of what it's going to look like. Cut me out of it. There you go. So the idea here, Alex, is we find the whole thing, the bigger pipe, and then we subtract the inner pipe. And then instead of it being 100, in this case, now the new question, it's only 12 meters long. I think this one had 12 in it as well. So that was number 8 of the practice. So if you go through that solution, you still have a question about it, fire me an email. I'd be happy to do it for you again. But I have a feeling once you look, you will no longer have a question about it. Somebody asked about the surface area of spheres. I forget who it was. I saw the question up above. Calculate the surface area of the volume of the following sphere. Maybe I'll just do this surface area of the sphere real quick. Maybe I'll do the hemisphere, because that's a little bit trickier. So the surface area is given on our formula sheet as 4 pi r squared, or pi d squared. And radius and diameter, you'll remember, is just 2 times the diameter, or 2 times the radius gives us the diameter. So I can just find the total surface area. So 4 pi, in this case the radius, gives us the diameter. The diameter is 20. So I'll just use this formula down here on the bottom. I'm going to go pi times 20 squared. So 20 times 20 is 400 times pi. 1256.6. So that's the total, but we only have half. So I need to divide that by 2 to figure out the hemisphere. 628. All right, and then the hint here, calculating the surface area, don't forget the bottom. So what shape do I have on the bottom? I just have the circle. So to find the area of a circle, I'm going to have pi times r squared. And in this case, the radius is going to be 10 because the diameter is 20. Pi times 100, 314, 59. And then I'm just going to add those two together to get the total. I'm not going to actually do that. I forget who asked about surface area, but hopefully that helps a little bit. The last, just have like 1 minute left, and first page of learning guide number 2. Maybe I can just give a couple pointers on that, Taylor, and then like this guy here, what would be the appropriate unit for measure of the following items? Is that the number 2 you're talking about? I'm assuming there's only one number 2 on the first page. So the height of a streetlight pole, we're going to estimate it with appropriate units. Streetlight, what would be a good unit to measure that? I'd probably guess meters. I know I'm 183 centimeters, so I'm like about really close to 2 meters. So how many of me would it take to, if I stood on my own shoulders? So maybe like 3.5 to 4 meters. The length of your thumb, maybe inches or centimeters. I mean, you could go 1 inch or 2.5 centimeters. The idea here is that they're trying to get you to figure out not exactly, but figure out just, kind of things reference, essentially. Things in your life that you can use to measure these things. Of course, on a test, it's not going to say, approximate the height of a lamppost, because the answers would be so crazy, but it could say, which one of these is close to the height of the lamppost, and then, give you a bunch of really weird numbers, and then just so you kind of figure out what they look like. So that kind of ends it. I apologize if you're hoping to get to Unit 1 today. Hopefully me going through some of that review and other things will help you guys out a little bit on the test. So you should be done the quizzes for Unit 2. You should get your review in as soon as possible. And as soon as I get that in, I'll get you a code so you can write the test. The test is exactly the same as the quizzes. So some of the questions are going to be multiple choice. Some of them will be kind of like that written response. One thing that I will mention is I will be able to, hopefully I'll have my computer with me tomorrow. We have a professional development. So if you send me your review tomorrow, I promise by the end of the day, at some point, like before 3:30, I'll check and I'll get you the code, assuming your review went kind of well. But I won't check my computer after 3:30 tomorrow. So if you want to, do the review over the weekend and then hand it in on Tuesday, I can get you the code and you can write the test Tuesday afternoon. Hoping everyone will finish the test by the end of the day on Tuesday. So the next time I see you will be then. The review gets handed in. Yep, there's a place in the course right here, learning guide submission. So just like we did the first review, you're going to submit that and I'll be able to get that back to you as soon as you get it in. A couple of people have handed it in. If you're having issues, let me know. If you have any questions, the remainder today I'll be at my computer, not so much tomorrow. That's kind of it. So if you have questions, send me a message in Moodle. Scan it or take pictures of it, submit it as one file, and that's kind of it. So that's it for me. I don't think you guys have English this afternoon. So good chance to maybe go through some of that math. If you have questions, you can send me a message. And we'll see you guys on Tuesday. Have a good long weekend. Enjoy your Thanksgiving if you're eating some turkey and things like that. Don't eat too much. See you later.